Hello to all the advanced level candidates out there. We start by apologizing for the 8 minutes late start. Welcome on board. And please indicate if you're online with us by a hi or a hello so that we know that you are there. So as we are waiting for the others to join, the votes for this week indicated that we should revise 2016, 2019 and 2020. So we are beginning with 2016 today and we will take half of 2019. On Sunday, the 27th, we are going to look at the remaining part of 2019 and we will complete 2020. Please, just asking you to indicate to remind your friends so that they can join us online. Once more, welcome to those who are there. Alright, if you are just joining us, please indicate by a hi or a hello. So we are beginning at once with this paper. Okay, so we begin at once. The others will be joining us shortly, I presume. Alright, so given that the roots of the equation x squared minus x plus 2 equals 0 are alpha and beta, find the quadratic equation whose roots are 1 over 1 plus alpha squared and 1 over 1 plus beta squared. The first thing to do with this equation is to make sure it is in the form x squared minus sum of roots plus products equals 0. X squared minus sum of roots plus products equals 0. So, welcome Iris, I can see you online, welcome. X squared minus sum of roots equals plus products equals 0. So this is identical to x squared minus alpha plus beta x plus alpha beta. So this equation that has been given to us is identical to this form that we have here. So it therefore means if we look at it identically, minus into alpha plus beta is equal to minus 1. So this therefore means that our sum of roots is equal to minus 1, which is alpha plus beta, and our product of roots, which is 2 here, is equal to alpha beta. So thus we have alpha plus beta equals 1 and alpha beta equals 2. At this point, we can now look for the new sum and the new product of our new equation so that we can form it. So our new sum will be given by, since the new roots that has been given here, they want us to form equation with these roots, 1 over 1 plus alpha squared and 1 over 1 plus beta squared. So our new sum will be 1 over 1 plus alpha squared plus 1 over 1 plus beta squared. We look for the LCM. Our LCM is 1 plus alpha squared into 1 plus beta squared. And when we divide by 1 plus alpha squared, we have 1 plus beta squared plus 1 plus alpha squared. When we simplify this, we will have 2 plus alpha squared plus beta squared. All that on that denominator. Equally, we know that this numerator can be expressed as well as denominator can be simplified in various forms. Let us see what we have. So we know that alpha squared plus beta squared is the same as alpha plus beta all squared minus 2 alpha beta. We see that in the numerator. The same thing in the denominator. We are going to replace that alpha squared plus beta squared by alpha plus beta all squared minus 2 alpha beta, and then we continue with the alpha beta all squared. But we already have these values up here. Alpha plus beta is 1 and alpha beta is 2. So we substitute these values into this equation and we will have 2 plus 1 squared minus 2 into 2. All that on 1 plus 1 squared minus 2 into 2 plus 2 squared. And when we simplify that, we will have minus a half as our new sum. So the new sum of roots is minus a half. The next thing we need is the new product. A new product is by multiplying what has been given to us. 1 over 1 plus alpha squared times 1 over 1 plus beta squared. And this will give us, the numerator remains 1. The denominator now becomes 1 plus alpha plus beta squared minus 2 alpha beta plus alpha beta squared, which is identical to this same denominator that we have up here. And so we can put in the values and simplify. That will give us a half. So a new equation which can be written in the form x squared minus sum of roots plus product now becomes x squared minus, our sum is minus a half and our product is a half equals 0. But it is not beautiful like that. Let us simplify. That will give us, that is multiplying all through by 2. We will have 2x squared plus x plus 1 equals 0. So guys, you can leave your comments as the class goes on. And one person complained last time that we should try to take it a bit slow. And so exactly we are bringing it down. We would like to say welcome to Chair Clovis. Alright, Madam Iris already said welcome to him. Please, those who are joining us online, don't forget to inform your friends that we are live online so that they can equally join this revision class. So today we are trying to bring down the speed because of the complaint of last time that we were a bit fast. The B part of this question reads, given that the polynomial p of x equals that and has degree of 3 is exactly divisible by x minus 1 and that p of 0 equals 10, find q of x. So this polynomial, the first thing is that it has a degree of 3. That means the highest power of x is 3. Then it is exactly divisible by x minus 1. That means x minus 1 is a factor. And you are being told that p of 0 equals 10. It means that when we substitute x by 0 in the equation, the remainder will be 10. So we are going to use all of these ideas to solve this equation. So first thing first, alright, a bit slow with connection, so yeah, please can you release. Okay, so first of all, since you have been told that our polynomial has a degree of 3, when we look at this p of x, you can already see, look at this point, you have 2x, and if you multiply this bracket by this other bracket, you will have 2x times x, that gives us 2x squared already. And looking at this q of x here, it therefore means it can only have a degree of 1. So we say let our q of x be equal to ax plus b. Why? Because this first term here has degree 1, this one has degree 1, therefore q of x must only have a degree of 1, such that the total degree should be equal to x to the power 3. Since this other one is just plus 2x minus 8, which is actually of degree 1. So our q of x equals ax plus b. So what we are required to do is to look for a and b and fit in that equation. We have been told that x minus 1 is a factor. It therefore means that if we equate x minus 1 to 0 and we have x to be equal to 1, our our p of 1 will give us a remainder of 0. Why? Because x minus 1 is a factor, or x equals 1 is a root. So when we substitute that into that equation, p of 1 will be equal to 0. This will give us minus 2 into, since x is 1, so we'll have 2 times what? 2 times, that is now a plus b, and all of that will give us 0. So when we substitute these values and simplify, we will be left with a plus 2 plus b plus 4 equals 0. Since our q of x, we have replaced it by ax plus b. Alright, so when we simplify, we will have the first equation in which a plus b is equal to 2. The next thing is to use the second idea that has been given, in which p of 0 is equal to 10. So if we substitute 0 into this equation, that is substituting x by 0, we will have p of 0 equals 10, and this is equal to 3b minus 8 when you simplify. So this gives us another equation, equation 2, but from equation 2 we have just one unknown, and from equation 2 our b is equal to 6. So substituting b equals 6 in equation 1, we will have a to equal to minus 4. So our A is equal to minus 4. Therefore, our Q of x is equal to what? Minus 4x plus 6. You can leave your comments and questions as the class goes on, and please don't forget to remind your friends to join us. It seems many people have not joined us today. I don't know. We are still waiting if they can send us messages on issues of connection, connectivity, and so on. Let's take the second equation, or the second question rather. So the second question of this paper reads, given the matrices M equals that and N equals that, find the matrix products Mn and Nm. So Mn will be equal to M times N, and this gives us, so the first row here times the first column, that is the first row in the first matrix times the first column in the second matrix. So this gives us 2 times minus 1 plus 1 times 5 plus 0 times 6. That is what we'll be doing. So that gives us this. So when we simplify all through, at the end, our result will be 300,030,003. Equally, when we look for Nm, one point to note, this one is the same like 3 times the identity matrix, right? The identity matrix has zeros elsewhere and ones along this leading diagonal. So now let us look for Nm. So for Nm, we'll be multiplying the matrix N by M. Alright, so here it is Nm. Okay, please. Here it is Nm. I cannot go back. So when we multiply these two, we are going to have the matrix, the same matrix. We obtain the same value, 300, 030, and 003. And this one is also the same as 3 times the identity matrix. This one is important because we are going to use this in the B part, as we are going to see. Now we are being asked to find the inverse of M. The inverse of M. So how do we find the inverse of M? Normally we can use this shortcut to find the inverse of M, and this is what we are going to do. We have seen that Mn is equal to Nm. So the word hence means, if you look at the B part here, this one is very important for advanced level because instructions must be followed. They said here that hence means you must continue with the results that you have in the previous question. So hence means we must use either Nm or Mn. So we know that Mn is equal to 3 times the identity matrix. Therefore, matrix M times 1/3 matrix N will be equal to I. And from this matrix product, what do we know about this? We know that if a matrix multiplied by another matrix gives the identity matrix, then one matrix is the inverse of the other. So from here, we see that M has an inverse of 1/3 N, because the product of these two gives us the identity matrix I, right? Equally, if you want to work in terms of N, we'll say the inverse of N is 1/3 M. So therefore, our inverse of M will equal to 1/3 times the matrix N. So we divide all through the entries of the matrix N by 3 to have this inverse, and this gives us the values which you can see. Alright, so that's what we have. Now, the C part, or the next part of the equation, is saying that a transformation represented by the matrix M maps the points A, B, and C to the points 306, 053, and 100 respectively. We should find the coordinates of A, B, and C. So according to this question, the transformation represented by this matrix M, so M here is our transformation matrix, it maps the points A, B, and C to a certain point. So we want to find the coordinates of A, B, and C. We don't know the coordinates of A, of B, and of C, but we know that A is mapped onto this first point, B is mapped onto the second, and C is mapped onto the third. How do we find the coordinates of the points that are mapped onto this? So we can use the inverse matrix, because we know from matrices that a transformation times a point gives the image of that point. Now they've given us the image and they want us to find the points that is mapped onto that image, right? This is it. So M maps P to P prime, but we have been given P prime and they want us to look for P. Therefore means that our P will be equal to M inverse times P prime. M inverse times P prime. So our P will be equal to 1/3 into M inverse, as we had before, is 1/3 into matrix N. Now times P prime, which has been given. So we take these points 306, 053 and 101 and form a 3x3 matrix with it. 301, 053 and 101, where 306 the point, the image A as shown, and B and C respectively. Alright, so when we simplify this, we will have 1, 1, 0, 1 minus 2, 2 and 0, 1, 1. So we can first of all start by multiplying this matrix by this one, and then when we have the answer, we multiply all through each entry by 1/3, and that gives us the point that is mapped onto that. So what is the image, or what are the points that we map onto A prime, B prime and C prime? So the point A is 1, 1, 0, B is 1 minus 2, 1, and C is 0, 2, 1. So those are the points. Okay guys, don't forget to subscribe to this channel, and you can visit our blog www.gcemathspanel.blogspot.com, where we have our online store with all the GCE materials that are there for you. Equally, on that blog we have the GCE Math Panel site. So online you can just type GCE Math Panel online classes, and then you type Google Sites just beside it, and it will take you to our online school page where you have all the lessons arranged by weeks and the preparations. Also to remind other students that our holiday classes will begin on the 26th of July. It begins on the 26th of July and will run from July to August. And equally, in August, we begin our full-time online preps. Full-time online preps is the preparatory classes that prepare students throughout the year with mocks at the end of every month. These are called the super mocks, which prepares you for the GCE. So you can start indicating using numbers that you have on our website and on the screen too for enrollment. Thank you. Now let us look at the third question. So question 3 reads, that's 2016 question 3 reads, given that the function f of x equals x to the power 3 is differentiable in the interval minus 2 to, use the mean value theorem to find the value of x for which the tangent to the curve is parallel to the chord through the points minus 2, 8 and 2, 8. So let us first of all recall, what does the mean value theorem states? It states that for a continuous and differentiable function on the interval AB, there exists a number C such that f prime of C equals f of B minus f of A, or that on B minus A. So let us start by looking for f prime of x. F prime of x will be equal to 3x, and f of B minus f of A on B minus A will be equal to f of 2, because you can see the limits here, right? From minus 2 to 2. So we have f of 2 minus f of minus 2, or that on 2 minus minus 2. So that will give us 8 minus minus 8 on 2 minus minus 2, which is equal to 4. So that's our f prime of x is equal to that. And the next thing we need now is this 3x, that is the f prime, right? F prime of x is equal to that, and we have looked for this other part, so we have to now equate these two. So our 3x squared is equal to 4, and x should be equal to plus or minus 2 on root 3. Plus or minus 2 on root 3. So that is the value of the x that we are looking for using the intermediate value theorem. You can leave your comments as the class goes on. Please don't forget, like I said, on Sunday we'll be looking at 2019 from questions 6 to 10, and 2020 the complete paper. Remind your friends, advanced level classes is at 9 p.m. Ordinary level classes are at 1 p.m. during the day. Alright, question number 4, or the B part of question number 3 rather. Expressed in the form y equals f of x, the general solution of the differential equation y dx dy dx equals x into 1 plus y squared. So we can solve this one by separating variables, right? Okay, so let us tackle this problem. So from here we can see that our y dy will be equal to x into 1 plus y squared dx, and when we divide all the two sides by 1 plus y squared, we have y over 1 plus y squared dy to be equal to x dx. We now introduce the integral signs. On the left hand side, if you differentiate the denominator, we will have 2y's. So to balance it, we will have write a 2 there and multiply it by a half, such that we have not changed anything in the equation, right? Now, when we integrate the left hand side, we'll have a half ln 1 plus y squared is equal to the right hand side, we'll have a half x squared plus a constant. Now, I want to make an emphasis here. Normally, I'm supposed to use the absolute value signs. Why have I not used it? I have the choice to leave it out because 1 plus y squared is always a positive number, right? It's always positive. If there was a possibility, if I had just something like 1 plus y, then I am obliged to put the absolute value signs because the line of negative numbers do not exist. But since this number is always positive, I have the right to put it like this. So now we continue to simplify. Here we have ln 1 plus y squared to be equal to x squared plus 2k. So we can replace that 2k's by another constant c because a constant is a constant. And from here, if we take the exponential of both sides, we'll have 1 plus y squared to be equal to e to the x squared plus 2k's. And this will be the same as e to the power 2x times e to the power 2k. But we can replace this e to the power 2k by a constant. Let's call it lambda, and this lambda should be an element of r. So from here now, our y should be equal to the square root of lambda e to the power x squared minus 1. Note that the minus 1 is inside the bracket of the other elements, where y lambda is an element of r. Well, I would like you guys to comment on our speed. I hope we are going at an appropriate pace that you can follow, because working on the last comments, we have decided to reduce our speed so that it can actually be well understood too. Please do not attend this class alone. Make sure you indicate to your friends and other WhatsApp groups and Facebook groups that we are live now, and we still have about an hour, so please indicate to them. That brings us to question number 4. Using the Moivre's theorem, express cos 4 theta in terms of cos theta. Using the Moivre's theorem, express cos 4 theta in terms of cos theta. So the Moivre's theorem states that's for multiple to single angle, right? Because cos 4 theta is multiple angle, and they want us to convert this to a single angle. So from multiple angle to single angle, this is the transformation that we use. So cos n theta plus I sin n theta, that is what we have, right? So so if you expand the right hand side and we compare the real and imaginary parts, we will obtain the identity. So this is what we are going to do. For the left hand side, we will say cos 4 theta plus I sin 4 theta to be equal to cos theta plus I sin theta, all that to the power 4. This is the Moivre's theorem, right? So we can use this. So the root power, the first power. Alright, we are up to the fourth power, right? You can see this one indicates that we are at the fourth power. So at this fourth power, let us do this expansion. So expanding the right hand side, or we can use binomial expansion. Can equally use binomial expansion, and we'll have the same value. So we have c to the power 4 plus 4 cos theta to the power 3 I sin theta plus 6 cos theta squared plus I sin theta squared plus 4 cos theta into I sin theta cubed plus I sin theta to the power 4. You can see the coefficients here, right? 1, 4, 6, 4, 1. Right now, when you simplify that, this is what we are going to have. But now this question that was given to us, cos n theta is actually real. So we can group them into the real part and the imaginary part. So this is the real part, this is the imaginary part. So what do we now do with this real part and imaginary part? we know that cos 4 theta is equal to the real part of cis 4 theta. So it's equal to the real part. So we are taking just the real part after that expansion, and that's what we have. So this one is now in terms of single angles, cos 4 theta minus 6 cos theta into 1 minus cos square theta plus 1 minus cos square theta, all of that squared. And this will give us 8 cos theta to the power 4 minus 6 cos square theta plus 1, which can be written like that. Now in the exam, you can write like that because you can express in terms of 6 theta, that is cos theta plus I sine theta, and it will be okay. So that's the first part of the equation. Now the second part of the equation, we have z1 equals that and z2 equals that, and we are given that z3 equals 1 over z1 plus 1 over z2, and we have to look for z3. So how do we get z3? Yeah, we can use a shortcut. So we know that z3 can be written as, we can cross multiply actually too. We know z3 can be the same as z1 plus z2 on z1 z2. Yeah, for some of you who do physics also, you can actually see that, especially the current rule, when you're connecting resistors in parallel. So as z3 there, or no matter how you do it, these are the results you're going to have. Z3 will be equal to z2 times z1, all that on z1 plus z2, right? We now put in the values and simplify. And when we simplify this, what results are we going to obtain? We will obtain minus 8 plus 6 i's, all that on 5 i's. So that's a z3, but it's not in the nice form. Find out that the i's can cancel out, right? We can further simplify to have 8 i's plus 6, all that on 5. I hope this one is understood. Okay, let us now move to the fifth question. The fifth question. Yeah, please don't forget to subscribe to this channel, and we have a lot of material for you at the blog. You can visit it after this, and some quizzes too. And we'll be starting our online holiday classes on the 26th of July, and our full-time preps in August, from the 2nd of August, to prepare students for 2022. Alright, question number 5 reads, the position vectors of the points A, B, and C are A, B, and C respectively, where A equals that, B equals that, and C equals that. The vector product AC cross AB is, so you have to find the vector product AC cross AB. So we first of all have to look for AC. And what is AC? AC is equal to head minus tail, where C is the head and A is the tail. Equally, AB is head minus tail, where vector B is the head and A is the tail. So our AC will give us 101 minus 306, and when we subtract, we will have minus 2, 0, minus 5. Similarly, for AB, we will have minus 3, 5, minus 3. We can now get our cross product. So our cross products AC cross AB will be equal to, there are other ways we can do it, right? I'm going to use this other form, minus 2, 0, minus 5, minus 3, 5, minus 3. So this will be equal to, when you finally do it, your final results will be 25 i's plus 9 j's minus 10 k's when you simplify. Okay, that's vector simplification. Now, the B part of the question wants us to look for the vector equation of the plane ABC. The vector equation of the plane ABC. So, since A was used to obtain AB and AC, the vector equation of the plane should be R dot n is equal to OA dot n, where our n is the normal to the plane with vectors AB and AC. Can you see you have A, you have A, that's why I have OA here. So if another point was given, we will do the same. So our vector equation will be R dot n equals OA dot n. So R dot, our normal to the plane is AC cross AB, which already have the value here. So we just put in the value, Now OA dot n is equal to 306, which is the point A, dot 25, 9 minus 10. So that is the vector equation of the plane r dot 25i's plus 9j's plus minus 10k's equals 15. That gives us the vector equation of that plane. Okay, question number 6. Express f of theta equals 8 cos theta minus 15 sin theta in the form r cos theta plus alpha, where r is a positive constant and alpha is an acute angle. It's an acute angle. So we have to express this in the form r cos theta plus alpha. Alright, let's see what we have. So first of all, we expand and equate the coefficients. So r cos theta plus alpha, when we expand, should be equal to 8 cos theta minus 15 sin theta. So when we expand, that we have r cos theta cos alpha minus r sin theta sin alpha. Note that cos theta plus alpha is cos theta cos alpha plus sin theta minus sin theta sin alpha. And with cos, when you have plus here, when you expand, you should have but minus. And if it is minus, when you expand, you should have plus, don't forget. And since the r is outside, it is both at this point and at this point. Now when we equate the coefficients, we will see that r cos alpha, because this cos theta will cancel out to this one, it's cos identical to this one, we'll be left with r cos alpha is equal to this 8 here. Similarly, we have minus 15 sin theta is identical to minus r sin theta sin alpha. The minuses will cancel out, sin theta will cancel out, I'll be left with r sin alpha is equal to this 15. Then tan alpha can now be given by, from here you can have tan alpha, right? Divide this equation 2 by equation 1, that will give us 15 on 8, because the r's will cancel out, and sin alpha and cos alpha is tan alpha is equal to 15 on 8. And from there, our alpha will be equal to arctan 15 on 8, which is 61.93 degrees. Note that arctan means tan inverse of 15 on 8, which is 61.93 degrees. And what is our r? Our r is equal to the square root of 8 squared plus 15 squared. That gives us 17. So you can just get these terms here. 8, you square 8, 15, you square it and take the square root. That gives us the value of r. We can now conveniently express this f of theta as 17 cos theta plus 61.93 degrees. Then we are equally being asked to find the general solution of that equation. 80 cos theta minus 150 sin theta equals 13. Equals 13. So how do we do this? Well, to do this, if you look at this equation very well, look at it very well, look at this 8 cos theta minus 15 sin theta. You said they have just multiplied all through by what? By 10. They have multiplied all through by 10 and equated to 13. So what do? We will take this value that we have here and also multiply by 10 and equate it to that 13. So when we multiply by 10, we'll have 170 cos that, and that should be equal to 13. So from here, cos theta plus 61.93 degrees should be equal to 13 over 170, and theta plus 61.93 degrees will be equal to arctan 13 on 170 plus or minus 360 degrees n. Why? Because the period of the cosine function is 360 degrees. Therefore, theta will be equal to arctan 13 on 170 plus or minus 360 degrees n minus 61.93 degrees. Now we are actually being asked to find the maximum and minimum values of 5 over f of theta plus 3. So initially, the solution that we had to that equation was when we multiplied by 10, and therefore f of theta is equal to 17 cos that's what we had before, And we know that the cosine function lies between minus 1 and 1, no matter the value of theta of the core. So it lies between minus 1 and 1, and therefore these are f of theta here, right? These are f of theta, which lies between minus 1 and 1. This is it. So all of this here should lie between minus what now? Normally cos theta lies between minus 1 and 1. Therefore 17 cos theta should lie between minus 17 and plus 17. So here we multiply all through by 17. And when we multiply all through by 17, you see that this is our f of theta here now, which is 17 cos this value. You can now see here, right? And this lies between minus 17 and plus 17. Now we now add 3, because that's our f of theta. We now add 3 all through. When we add 3 all through, we will have minus 14 to be less than or equal to f of theta less than or equal to 20. So we'll add 3 all through, and you can see now this denominator appearing here, right? So this is what we have. So it therefore means that for f of theta plus 3, the minimum value is minus 14 and maximum value is less than 20, right? Therefore you can get the minimum and maximum values from here. So it will be 5 over 20 for the maximum. Let us see what we have. So the mean, let's start with the mean. The mean value will be 5 over minus 14. Why are we taking this one? Because this value here is negative. So when you divide, the answer is always going to be negative. So you have over minus 14. And the max will be 5 over plus 20 because it's positive. So those are the maximum and minimum values of 5 over f of theta plus 3. Question 7. Express f of x equals 5x minus 3 on x plus 1 into x plus 3 in partial fractions. So this is actually the first case with partial fractions. This is identical to a over x plus 1 plus b over x plus 3. We now multiply all through by the LCM. The LCM is x plus 1, x plus 3. So when we multiply all through by that LCM, we'll be left with 5x minus 3 on the left hand side equals a into x plus 3 plus b into x plus 1 on the right hand side. Now when x is equal to minus 3, this one here, x is equal to minus 3, this term will disappear or cancel out, and we will be left with, when you fit in minus 5 times minus 3 is minus 15 minus 3 minus 18 to be equal to minus 3 plus 1 is minus 2 times b minus 2b's, and therefore our b will be equal to 9. Now when x is equal to minus 1, we are using this equate to 0 and solve. When x is equal to minus 1, you will have minus 8 to be equal to 2a's, and a will be equal to minus 4. Therefore our f of x will be equal to minus 4 on x plus 1 plus 9 over x plus 3. Then after that, hence evaluate the integral from 3 to 5 of f of x dx. Here again, I would like to emphasize that we have the word hence coming in. It means that we must use the previous answer to continue. And in doing this, so we integrate f of x dx from 3 to 5. We can break those integrals into 2, right? So yes, when you integrate, we will have minus 4 ln x plus 1 plus 9 ln x plus 3. Now note here that normally what you must use here are the absolute values, right? Because x can take negative values and ln will not be defined. So absolute values, note here absolute values, not these brackets that I've used. Absolute values, and equally here. So now we fit in the limits. We'll have 0.967 when you put in the limits, 0.967. Question number 2, given that f of x equals that where x is greater than 0 and taking 1.5 as the first approximation to the root of f of x equals 0, use the Newton-Raphson procedure to obtain the 3 decimal places a second approximation of the equation. So we have f of x equals that, and the first root is 1.5. They want us to get the first, or rather the second approximate root, because 1.5 is the first approximate root, the second approximate root using the Newton-Raphson's procedure. So let us look at Newton-Raphson. Newton-Raphson states that x1 is equal to x0 plus f prime on f of x. So f prime of x will be equal to 10x. When you differentiate, you'll have 10x minus 2 on root x when you differentiate that. And what will be our f prime of 1.5? F prime 1.5 will be 13.367. Now let us apply our Newton-Raphson to get the second root. A second root, let us call it x1, because the first root is always x0, right? X1 will be equal to x0 minus f of x0, all that on f prime of x0. And we put in the values that we have above and simplify. And what does that give us as the answer? That gives us 1.473. That's the second approximation of the root of that equation. 1.473. Question 8. Find a set of values of x for which x plus 2 on x minus 1 is less than 3. We first of all bring everything to the left hand side. So on the right hand side we have 0. By looking for the LCM, we will have the left hand side to be minus 2x plus 5 on x minus 1 to be less than 0. So from here we can use the number line or we can use tables. Now we know that the boundary solutions, if you solve this, equate numerator to 0, the boundary solution will be 5 on 2, denominator to 0, the boundary solution will be 1. So we can test now to see the range or the region where we are going to have a value that is negative. Now let us take, if you take below 1, take 0 for example, and fit 0 here. If you put 0 here, you will have 5 over minus 1, which is less than 0. So this region satisfies, right? And therefore the region above 5 on 2 also satisfies. So that is our solution. So I've given it an interval from negative infinity to 1. 1 is not included, as you can see, and from 5 on 2 to plus infinity, and 5 on 2 is not included. Now sketch the graph of f. So I want us to sketch the graph of f. So let's see how we sketch the graph of this. So what are some of the characteristics that we have to look for while sketching the graph of this function? We need the domain. We need to get the asymptotes, the limits, the turning points, and the intercepts before we sketch. So from here we have our f of x to be equal to that, right? So now we can start by looking at, we already have the domain as x not to be equal to minus 2 of that function, and here the b part is that we should find the range. So let's first of all look for the range. That's the b part, and then we can now sketch. So to look for the range, equate that function to y, solve for x, and you have the inverse function, right? The inverse function will be x is equal to 2y plus 4 on 3 minus y. Why are we doing this? Because the range of a function is equal to the domain of the inverse. So we are trying to look for the inverse function. When you have the inverse function, we will look for the domain of that inverse function. The domain of that inverse function will be equal to the range of the function. So the inverse of this function is 2x plus 4 on 3 minus x. And for the function to be defined, the denominator must not be equal to 0. So 3 minus y should not be equal to 0, and y should not be equal to 3. Therefore, the range of the function is a set of all real numbers excluding that 3. We can now sketch the function as the b part requires or stipulates. So to sketch, let's see what we have. Okay, it's a bit slow. So let's sketch this function. So the domain is a set of all real numbers excluding minus 2. As you can see here, it's actually written here, x should not be equal to minus 2. Now we have 4 bounds at this domain of definition. You have minus infinity, minus 2 from above, and plus infinity. So let's take the limit of f of x as x tends to plus or minus infinity. We can combine these two because degree of numerator equals degree of denominator, right? So when you take the limit as x tends to plus or minus infinity, we just have to divide highest by highest. So 3x divided by x gives us 3. So it therefore means our limit is equal to 3, as you can see. Now the limit as x tends to minus 2 from below. What do you mean by minus 2 from below? Just take a number that is very close to minus 2, but it should not be far away because functions can behave differently when you move far away. So for minus 2 from below, take a number that is less than minus 2. Minus 2.1. Note that minus 2.1 is to the left of minus 2, so it's less than minus 2 and fits in the function. When it fits in the function and simplify, you will have a positive value as answer. Therefore means that the limit is positive infinity. Now let's take minus 2 from above. Minus 2 from above, take a number that is slightly greater than minus 2. You can take minus 1.9. When you fit that in the function and simplify, you will have a negative number, and that implies that the limit is negative infinity. From here, you can now get the asymptotes. The vertical asymptote is, you can see it from the domain of definition. Now x should not be equal to minus 2. So x equals minus 2 is the vertical asymptote, the function of x that will make the function undefined. And the horizontal asymptote is obtained by saying that the limit as x tends to infinity. And as x tends to plus infinity, we had 3. As it tends to minus infinity, we have 3. Therefore means that the line y equals 3 is the horizontal asymptote. Now, whenever the degree of numerator is equal to the degree of the denominator, we have a horizontal asymptote. If the degree of the numerator is greater, we have whatever asymptote, an oblique or a slant asymptote. And if the degree of numerator is less than that of the denominator, then a horizontal asymptote is equal to 0 when you take the limits. Okay, now the next thing you have to do is to get the intercept. When x is equal to 0, what will be the value of y? Y will be minus 2. If y is equal to 0, we substitute x will be equal to 4 on 3. So those are the intercepts that we have. Now the gradient function or the derivative, y prime will be equal to bottom constant, that is x plus 2. You differentiate the top, you have 3, minus the top constant, minus 3x minus 4 constant, differentiate the bottom, you have 1. All that on bottom squared, x plus 2 all squared. So what does this give us? So when we simplify, we'll have 10 over x plus 2 all squared, and this is strictly greater than 0. This value being strictly greater than 0 implies that this function is increasing. How do I know that it's strictly greater than 0? The numerator is positive and the denominator is x plus 2 squared, which is always a positive number. Alright, excuse me. Okay. Now, if you look at the numerator here, there is no variable, there is no x to solve for. It means that there is no turning point because there is nothing to solve for, so there is no turning point. Since there is no turning point and the function is strictly increasing, we can now go to the table of variation. Or we can equally sketch down the table of variation because I have not asked for it. So when we look at this function, you see that y values, according to the limits, the y's are not very far from the origin, and the x values according to the domain, minus 2 to plus 2 can do it, but you have to extend a bit. So our horizontal asymptote is the line y equals 3, and this is indicated by broken lines. And we have a vertical asymptote, x equals minus 2, right? And whenever you have a vertical and a horizontal asymptote like this, it means the function is symmetrical. Now let us see how we sketch. So when we look, we see that minus 2 from above Look at the limits of minus 2 from above. The function is a negative infinity, right? So minus 2 from above, we have this line around this area. And it moves as x is tending to plus or minus infinity. The limit tends towards to 3. So it moves towards this direction. And there are two intercepts here. It crosses at 0 minus 2, as you can see, though it's not really well drawn, and 4 on 3, 0. X is 4 on 3, y is 0. And then equally, this function, as x tends to minus 2 from below, what did you have? This is here, minus 2 from below. The function was at positive infinity. So the line will start up here at positive infinity and will come down like this, such that this is symmetrical. Yeah, that's it. And this point here where these two lines intersect is called the center of symmetry. And how do we get the center of symmetry? It is the x value comma the y value. That's the point. If there are two vertical asymptotes, then we take the average. That's where the center of symmetry will be. The average of the x values. Okay, we have sketched. Now let's move to question 10. Question 9 rather. In this question, you are to work throughout with two decimal places. So this question has a specification. We have to work throughout with two decimal places. The table below shows the values of x obtained in a certain lab work. The variables are connected by the equation y minus 2 equals b into x minus 1 to the power a. So that's what we have. Now that by drawing a suitable graph of log 10 of log y minus 2 base 10 against log x minus 1 base 10, estimate the values of the constants a and b. So we have to first of all look for y minus 2 and take the log of it, right? Y minus 2 is equal to log 10. Okay, so when you take log on both sides of this equation that's been given, this is what we have. You have log 10 that. So we want to see how these things came about, right? So I can get the relationship and get the gradient of this function or this curve when it's being plotted. So we take log on both sides from the equation that's been given, and we'll have log y minus 2 base 10 should be equal to log b into x minus 1 to the power a base 10. But the right hand side can further be simplified as log 10 log b base 10 plus a log 10 log x minus 1 base 10. Note that this is the product of numbers, right? From the first law of logarithm. Good. And then this pi, you can bring it in front. Yeah, from the law of further powers. So this is what becomes of this linear relationship, or of this relationship that exists, and it has the form c plus mx. So now let us look for our log x minus 1, and so for each of the values we have that. So for each x value, we subtract 1 from it and take the log. We subtract 1 from it and take the log and complete the table. Now for the y values, we take each y value and subtract 2 from it, and then we take the log of the result. So log y minus 2, and that is what it will give us. Now we can now sketch our curve, right? So the values that we have. So we know very well that these values are all positive. So we can work with the y ranging from 0 to 1. If you look at all of these values here, moving around from 0 to up to 1. And then for the x values, what do we have? You can equally have from 0 to, or from 2, 0.2 to 1.4. The larger graph paper, you can use a larger area too. So we are sketching the points when x, or when log x minus 1 is 0.22, we have 0.92, 0.58, 0.65, and so on. You can now link all of these points to the straight line. You see that all of the points fall on the straight line, right? So we have sketched. From here, you can now get the gradients by looking for a very large triangle like this. And at the point A, let's call this one our point A, we have 0.3 for x and 8.6. Another point down here, B, with coordinates 1.28, 1.6. So how do we get our gradient? Gradient is changed in y on change in x. Our change in y is 7.00, and our change in x is minus 0.98. So our a is changed in y minus divided by change in x, right? So it's be changed in y over change in x, and that gives us 7.14. While intercept, our intercept here is log b base 10. And what is this intercept? You can read the intercept from here, right? It's 0.94. So this 0.94 is equal to log b base 10. And from there, our b will be equal to 10 to the power 0.94, which is 8.71. We have put the values of a and b. Now the last question for this paper, this street paper. Find the term independent of x in the expansion of x squared plus 1 over 2x, all of that raised to the power 6. Find the term independent of x. So the term independent of x, that is the t r plus 1 term, is given by n combination r a to the power n minus r b to the power r. So this gives us 6, where this 6 is coming from this power here, combination x squared. The first entry here is x squared to the power 6 minus r. We have to look for r, because r will give us a help to give us that term independent of x, times b to the power r. B is 1 over 2x. So since the term is independent of x, all of these values should be equal to x to the power 0, right? Because the term is independent of x, and x to the power 0 means independent of x. So when we simplify this, we'll have 6 combination r times 2 to the power minus r times x to the power 12 minus 2r minus r. Thus, we have x to the power 12 minus 2r minus r to be equal to x to the power 0, because it's independent of x. And from here, equating the powers, you have r to be equal to 4. Therefore, a term independent of x is equal to r plus 1, which is 6 combination 4 star 2 to the power minus r. So we come back to this equation, right? Which is 5 on 4. That's the term independent of x. The B part of the equation says a geometric progression with positive terms has sum of its first two terms as 20 on 3, and its sum to infinity is 12. Find the first term and the common ratio of the progression. So you can see that the first term and the common ratio are respectively that. Now the first term, the sum of the first two terms is 20 on 3. The first term is a and the second term is ar, so that gives us 20 on 3, right? So a into 1 plus r is equal to 20 on 3. Now we are equally being told that the sum to infinity is 12. And how do we get the sum to infinity? Sum to infinity is the first term all over 1 minus r. And so that gives us now these two equations, which you can conveniently solve. So here we are going to have 12 into 1 minus r into 1 plus r to be equal to 20 on 3. Right? Yeah, because now we know that our first term is a, right? And this is a. A is 12 into 1 minus r. And equally, we know that the common ratio is 1 plus r. So this gives us this. From here, you can solve for r, and r will be equal to 2 on 3. Therefore, our first term, when we substitute, will give us 12 into 1 minus these 2/3, which is equal to 4. And the sum of the first three terms will be equal to a into 1 plus r squared, which is 4 into 1 plus 2/3 plus 4 on 9, which is 39 on 8. Alright, thank you so much, viewers, for being there. You can equally use the formula. Thank you so much. So this is where we end with the revision for 2016. On Sunday, we'll be revising 2019 and 2020. Please inform your friends, because that will be our last revision. Note that when the GCE starts, we cannot continue with our revision. Please can equally visit our blog. We have a lot of material there for advanced level, which can help to prepare you for the exam. Don't miss the class on Sunday, because Had I Known is a story for the gods. Welcome to the GCE Math panel, and thank you so much with the collaboration of Maths 24 and the technical expertise of our friends in other foreign countries who are giving us technical support. We thank you so much for being there. Please don't forget to share this message and to subscribe to this channel, so that whenever we upload a new video, you'll be notified instantaneously. Thank you so much. We love you all, and bye bye.